We did number 1 yesterday. There it is. We found that we had a slope of undefined because our denominator was 0, right? Is there any questions on the front specifically here that you would like to see gone over? Anything that gave you trouble or you were a little confused about? There you go. Yes, Devin. Number 5, beautiful. That'll be a good one for us. Let's just go ahead and jump right into number 5. Because number 5, as you may have found, does not give us a 0 or undefined slope. It's just a regular slope problem. But the reason why this is included on here is because they're trying to trick you. Let's go ahead and set this up. x1, y1, x2, y2. And I'll explain why this is a somewhat tricky problem. We'll plug it in if we got y2 minus y1 over x2 minus x1. That's going to give us 3 minus negative 3 over negative 6 minus negative 3. So, I talked before about how our parentheses contain our negative signs, contain our negative signs in there, right? So that we know that this is a negative 3. But if we don't do that, right? If we just do 3 and negative 3, we'll get 3 minus 3 on the top, and that would give us that 0. So if you got 0 as an answer for number 5, I understand why you may have gotten that. But let's see why that's not the case. With those parentheses, we contain this negative sign with that 3, and we have a minus sign still in the middle. What happens when we see 2 negative signs right next to each other? Positive. They make a positive. So we don't have 3 minus 3 on the top. We have 3 plus 3, which is equal to what? 6, exactly. We got a double negative on the bottom again. Those make a plus. And negative 6 plus 3 gives us negative 3. There's neither a 0 on the top nor on the bottom. So we're going to have a regular slope here. How can we simplify 6 over negative 3? What's that equal to? 2? Negative 2. Good. 6 divided by 3 does give us 2. Nice and whole right there. But a positive over a negative is always going to give us a negative. That's right. Questions I can answer about 5? Yeah. Okay. Question about another question? Which one? Number 3? Perfect. Let's go right on up to 3. This is another one of these non-zero or undefined ones here. But the trick with this one is we see that we've got 2 8s here. And when they're right next to each other, your brain might tell you, oh, 8 minus 8, that's going to give us 0. But we got to make sure that we're plugging them in correctly. That should be y2. y2 minus y1 is 6 minus 8 over 14 minus 8. So this problem is trying to trick you into subtracting 6 minus 14 and 8 minus 8. That's why labeling each of these coordinates is super, super important. What is 6 minus 8 on the top?
2.
Negative 2, right? There is a 2-point difference between 6 and 8, but if we're subtracting a larger number, we're going to end up in the negatives, right? What about 14 minus 8? Positive 6 are larger numbers in front. If we take 8 away from 14, we've still got some positivity left. Now this is where I saw a lot of people get negative 3. Is that going to be our answer here? No. It's very close, but it's not going to be our answer. We know our fraction is going to be negative, but on the top, 2 is just 2 times 1. 6 would be 2 times 3. I realize that you guys don't have red pens. I apologize. Just make your corrections in pencil. That's fine. What can we cancel from the top and bottom here? The 2's. Now this 1 on top, we have to keep it up there. Okay? We can't get rid of that 1. Negative 1 over 3 is going to be our answer for number 3. Does that make a little sense? Whenever our smaller number is on the top of our fraction, our answer is going to remain a fraction. But as we saw in number 5, the larger number was on top, we get a nice whole number. It's one of those things that we really have to make sure we've got down by now. Hopefully you see what I'm talking about with the difference between those two. All right, let's flip to the back real quick. I know down at the bottom we may have had some trouble. I want to take a look at 13 and 14, okay? Is there anything else that anyone would like to see gone over besides 13 and 14? All right, then we'll stick to that. I don't know about you guys, but I'm exhausted today, so we're going to try and make it through. Despite that, so number 13, is this a perfectly vertical line? No, it's really close to being vertical, but you can see it's got a little bit of a slope to it. So we're going to have an actual slope here. If we start on the left and work towards the right, we're going to count up 1, 2, 3, 4, 5, 6, 7, 8 spaces up. And how many spaces over do we have to go? Just one space over. Now we have to be very careful, especially with these small graphs when we're doing this, because our brain wants us to just count along that diagonal line and go 1, 2, 3, 4, 5, 6, 7, 8. Right? And then some of us may have done something like 8 over 0 and gotten undefined. That is not what we do here. Our rise was 8. Our run was 1. Even though it's a really thin slope triangle, it's still a slope triangle of 8 over 1, which is equal to what? 8. There we go. Positive 8 there for number 13. It's only going to be undefined if it is perfectly vertical, straight up and down, kind of like number 14. Number 14, there's no leftmost point for us to start at, so I'm just going to start on the bottom point. I'm going to rise up 1, 2 spaces. And how many spaces do I need to run over? 0. I land right there on my point. So you may think, oh, my slope is 2. No, the rise over the run gives us 2 over 0. We didn't run over at all. And anytime we divide by 0, what's our slope going to be? Undefined. Good. Undefined. Got to make sure that we're solid with rise over run. Like I think I mentioned earlier this week, we're going to take a quiz tomorrow. All right? Yes, sir. We'll typically always take a quiz in the middle of each unit, right? So in Unit 2, we took a quiz after 2.1D. We had a quiz right there. Now we're on Unit, 3. We're about halfway through, so we're going to take a quiz tomorrow on Friday, okay? Just for me to see how we're doing with this stuff, where we may need to spend extra time reviewing before the test, and especially before our final exam, all right? Last one I want to do is number 12. What type of line do you see in number 12? What type of line? Is it vertical or horizontal or diagonal? Horizontal. Horizontal, right? So if we count from left to right, how many spaces do we rise up? 0. We don't have to rise up at all because those points are on the same level. But we're going to run over 1, 2, 3. So rise over run is 0 over 3. Anytime we have a 0 on top, our slope is going to be equal to what? 0. And remember, if I'm walking around the classroom on a flat surface, that requires about 0 effort. If you're walking flat on a treadmill, like we talked about yesterday, the incline of that treadmill is set to 0. So when you see a flat line, think about a slope of 0. Yes? What about number 11? Say that one more time. I'm having a hard time hearing what you're saying, but we'll go over number 11 because it might clear it up. This is another one of those ones where it's easy for us to just count on the diagonal, but we have to make a triangle. There's my leftmost point. I'm going to rise down one space and then run over, bless you, one space. See that little triangle I just made? It's very, very small, but we still have to make that triangle right in there. So if I rose down one, what's my rise going to be? -1. I'm going down, right? All these negative numbers down here below the graph gives us -1. What was my run again? +1. And what's -1 over +1 going to give us? -1. 1 over 1 is 1. Negative over a positive is a negative every time. And even if you forgot that rising down gives us a negative rise, if you just got +1, take a look at this graph. And I know for a fact I brought this up to a couple people yesterday. From left to right, are we going uphill or downhill on this graph? What do you guys think? Take a look at that graph. Are we going uphill or downhill from left to right? We're going downhill. Anytime we have a downhill sloping line, our slope is going to be negative. All right? Just like this little diagram that we talked about. From left to right, if you're going uphill, positive slope. Left to right, if you're going downhill, negative slope. All right? Does that answer your question, Devin? I apologize. Okay, perfect.